Hi there, welcome to your next video. This one is looking at absolute value inequalities. So this is going to look a little bit different than what we just wrapped up. So you're going to see here's the original absolute value away from 2. So you can see I have positive 2 and you can see that I have negative 2. And again, both of those are solutions because again, we're looking at how far away they are from 0. So that's kind of what makes that split happen for us. So now we're going to take a look at what happens when I start adding inequalities to the mix. For example, what happens when x, the absolute value, is less than or equal to 2? Well, that could be numbers like the number 1, for example. That would fall in line because I could do the absolute value of 1, and that would be less than 2. And here's negative 2, and even things like -1, that would also work because I could plug in absolute value of -1. Oh, yeah, that would also be less than or equal to 2. So I'm going to close these dots because I can be equal to, and all of our solutions would occur anywhere on that part of the number line. So something like that we can write in two different ways, one with interval notation, so all the numbers between -2 and 2, or we can write them in set notation. So we have all the values of x such that x is greater than or equal to -2 and less than 2. So it has to be between those numbers. So above -2 and less than 2. So this type of situation is called a conjunction. So it's that connectedness, that connected piece. So let's look at the other way around. What happens when we're looking at the absolute value is greater than 2? So again, I'm going to go ahead and close this dot right here at 2. Well, that's numbers like 3. That's numbers like 4. And we kind of have the numbers on the other side. So things like -3, numbers like -4, because again, I could plug that in over here and see, oh yeah, that would be greater than or equal to 2. So this solution set looks a little bit different because it's this piece, or it could be this piece. So it's this or it's that. So when that tends to happen, again, here's that little skip. Looks like we have to hop over some numbers. Well, I'm sure you know where this is going. You have to hop over. There's that union. So we have -infinity up to -2 with a bracket, or 2 and above that. So here's our set notation with the or. That situation is called a disjunction. There's a disconnect going on. So an easy way that I like to remember this type of situation is GreatOR. So there's that or situation with the union, or less than. So again, x is greater than -2 or less than 2. So it kind of looks something like that. So it's kind of has to fit that condition. So it kind of combines those pieces. So you'll also see on mine that all of my absolute value signs are on the left side of the inequality. That's going to help you decide that greater or less than trick. So definitely something you want to kind of keep in mind. I also have a fun did you know fact about camels that involves absolute value inequalities because their temperature can vary 3 degrees upwards or 3 degrees downwards. It's just not exactly 3 degrees. It could be 2 degrees, 1 degree, a half a degree. But that's just a fun little did you know fact about camels that are quite fun in my opinion. So here, I went ahead and graphed this ahead of time because I wanted us just to focus on the ideas. Plus, we're not really focused on transformations. But if you're wondering, here's where we went left by 2, and you'll see that part in purple. And this, that -2, that's that red part that I graphed. So here's y equals -2. So you'll see this absolute value piece we're looking at, is it just above -2? Well, that's all of this spot, all of this up here. You're going to see that entire graph is above -2, which kind of makes sense because these absolute value bars turn everything positive. Well, I'm pretty sure, by pretty sure, I mean like 100% sure that positive numbers are always above negative numbers, no matter what my heart desires. So this type of situation would be in all real numbers. We can pick any value for x and it will work 100%. Okay, so what happens when I go the other way around? When I have that x is less than, that whole less than piece, well, I'm going to put this in red because that's everything below here. Well, there's no graph that's below there. And again, that kind of makes sense because here we have a situation that says positive numbers are less than negative numbers. Well, again, I'm pretty sure that's never going to be the case. So when you see something like this, you have a no solution situation because there's nothing that would work there because positive numbers are never less than negative numbers. I love those situations. I think they're kind of fun. So when we start to solve by algebra, we have a couple of steps. So the first step that we're going to have is the absolute value absolutely alone? Always isolate that absolute value. Then you're going to decide, is it a great or a less than situation? So do I have two disconnected pieces or one connected piece? Step 3 is I'm going to separate if I need to and drop those absolute values. Solve both my inequalities all the way down, and then the final step is to write my solution set with a number line and then set or interval notation. So let's go ahead and try one together. So it looks like, I do need to isolate the absolute value. So step 1 says I need to do some isolation. So I'm going to add 4 to both sides of the absolute value. So I'm going to say, okay, here's 3 plus 2x. And then I've got something like this. And then now I have the number 13. Okay, absolute value is isolated. So step 2 says I need to decide, is it a great or a less than situation? So here's my symbol. The absolute value is a great or than 13. So I'm going to write great or right here. So that's step 2, deciding which one it is. All right, 3 says I need to go ahead and split these up. So I'm going to have one piece. So the absolute value piece, whatever that is going to be less than or equal to negative 13. So things like negative 14, negative 15, negative 20. Or the absolute value piece is going to be greater than or equal to 13. Numbers like 14, numbers like 15, and 16, and 17, all those lovely numbers. I'm going to go ahead and kind of draw a little shaded bar here to kind of keep my work nice and separate. All right, step 4 says I need to go ahead and solve. So I've split it, and now I can solve. And you'll kind of see all of these have the same steps, which is kind of nice that you get to kind of repeat your steps. I think it makes it a little bit easier. All right, so it looks like I have 2x on one side, and then I've got negative 16. I bring this down. You can always, some people really like drawing the arrows. I think it can help. So I'm going to bring those symbols down. So you really got to keep track of your absolute values. I think that's what makes these particularly sneaky. All right, so I have one that says x is less than or equal to negative 8 because I divide by 2. And then this one says, or x is above or equal to 5. Final solutions. So now I'm going to go ahead and create myself a number line. And I'm going to graph them on my number line so I can see what this looks like. And then I can do my final solution set. So I've got here is negative 8 on my number line. Here is the number 5. I've got closed on both. And I have, okay, everything is below. So that's right here. Everything is above. So that's right here. All right, just need to write my final answer. So I'm going to have negative infinity. So negative 10, negative 20 to negative 8 with a bracket because I'm equal to, union to skip over, bracket to be equal to 5, upward to infinity. So things like 6, 7, 10, 11, what have you. Okay, so let's go ahead and try the next one. Okay, first things first, I need to isolate. I'm going to go ahead and label my steps if you wanted to. So here was step 4 was algebra, and step 5, writing the final answer. All right, same thing here. I need to do a little bit of isolation, so I'm going to add 2 on both sides. Ooh, the dreaded fraction. Of course it was going to come back to us. I'm just going to leave it on the outside as is for now. So I've got 4D, D for desert, I suppose, plus 6. I've got There is 12. Okay, I'm going to try to clear this fraction. So I'm going to multiply by 3, multiply by 3. And now, so you can see I've canceled those out. The 3's are gone. And I'm going to divide by 2 so that I can get rid of the 2's. So divide by 2. All right, so I'm going to do 4D for desert plus 6. All right, is less than 18. So I did 36 divided by 2. Or you could do 12 divided by 2 is 6 times 3. So any way you see it, but hopefully 18. All right, now I need to decide GreatOR, less than. Ooh, this is a less than situation. So less than. So what that means is I'm going to do the first piece. So I got 4D plus 6 is going to be numbers less than 18. So things like 17, things like 16, 15, 10. And it has to be greater than negative 18. So things like negative 17, negative 10, because all of those would work. And now we do the same thing we did on that last one. This one just looks a little different when we solve because it's a compound inequality. So I still get to solve the way I did on that last one. So I'm going to go ahead and subtract 6 from here, subtract 6 from here. Ooh, 6 from here. So it definitely looks goofy. I know we're not quite used to that. All right, so I'm going to have something like negative 24 on this side. Ooh, man. 4D is left in here, so I'm going to drop those out. 18 minus 6, we have a 12. And then I'm going to keep these symbols all the way through. All right, last step is to divide everything by 4. Almost there. Look at that. Everything gets a 4. Every single thing gets a 4. All right, so I've got negative 6. X is greater than negative 6. And it's less than 3. So when I write that final step, again, I'm going to draw myself a nice little number line. I'm going to make it a little shorter so I have room here. Oh, it's still faded, but that's okay. So I have things like here's negative 6. I'm going to put 3. I'm going to have to bump that down there. This is a little different because now I have open circles and it's between. So that's where the and piece is coming in because you can see it's kind of shared between those. Here you go. It's a little bit easier. You can do that in set notation. You can do it in interval notation. If you choose interval, just make sure it's negative 6 to 3. It's kind of goofy because it looks like a point. If you're wanting to choose set notation, just be sure to include those bars because it's a set of x values. See? Not too bad. I know they are a little bit goofy though. Okay, so we're going to try one down here. Ooh, I have a watch out. I have a warning. Okay, so here's what makes this one a little bit interesting. Okay, let's try to isolate the absolute value. Well, I see I'm dividing by a negative 2. Okay, so I need to multiply both sides by negative 2 times negative 2. Okay, so those are going to cancel out. It's pretty nice. All right, absolute value looking good. Ooh, I multiplied by a negative number. Got to flip that inequality when we do that. That's an old Algebra 1 skill. We haven't seen that in a while. So instead of that way, I'm going to go this way. And then I have 3 times negative 2 is negative 6. Interesting. I now have a positive number because its absolute value is less than or equal to a negative number. I'm sorry, that's silly. So this type of situation is a no solution. Negatives are never greater than positives. You may have already seen that at the beginning of the notes. So if you were somebody, I'm going to go ahead and erase this because I'm going to show you what it could look like from the beginning. So if you happen to see this right here, this is a negative number because it's negative a half. Well, absolute value, this is a positive number eventually. We don't know when, but it will be eventually, is over here, a positive number. Well, a negative number times a positive number is still a negative number. And again, negative numbers are not greater than positive numbers. So either way, you get the exact same solution. Isn't that nice? It's almost like I planned it. Almost. Go ahead and I'm going to let you try example 6 on your own. I want you to see what you can do. And then go ahead and hit play so that you can see it. Okay, welcome back. So I'm just going to walk you through example 6 real quickly. This was a little bit longer. So here, hopefully you added 13 to both sides. So you should have gotten positive 8. And then you can see that I divided everything by 2. And then it looks like I made it a 2W instead of a 3W. So Miss Hawkins is just going to erase that and pretend like that didn't exist. We're going to make this a 3. Look at that. It's almost like it wasn't there. Still divided by 2, so that's still correct. And then I bet Miss Hawkins is going to have to fix some work here. It is a less than situation. So again, I'm going to go ahead and briefly fix this. So hopefully we have a 3W plus 8. All right, so this is where I'm going to do the and. So I'm going to go ahead and drop those absolute value bars. And again, I'm going to switch this, make it a 3. Man, you can really see how much that work kind of carries you through. Okay, so less than, so I'm going to be between -4 and 4, so I'm going to subtract 8 on all 3 sides, bring the 3 down, divide everything by 3. So I'm going to switch this out for you guys so that you can really see that a little bit more clearly. Man, it really throws off all the numbers, but hopefully you can see that the ideas are still there. So I'm going to go ahead and put a 3 here, so 3W, and then divide everything by 3. And that's okay if these numbers don't look so pretty. Look, we ended up with a fraction. That's okay. So hopefully on one of them, you should have it between -4 and -4/3. Oh man, no wonder I was trying to make the numbers nicer, I guess, but that's okay. It's good to be comfortable with numbers that aren't whole numbers, so that's okay. So be sure for your final solution, you have it between -4 and -4/3. And again, you can put that on a number line if you'd like. You can put that in a set. So again, it's kind of whichever way, but I would know how to recognize it in all the different ways. So to recognize it from a number line, but to also recognize it from a set notation and to recognize it from an interval notation, making sure I didn't drop an equal to, because I'm known to just make up some stuff with these math problems. So I'm going to fix these numbers for you guys. So here's -4. My 4s are looking a little funny. -4/3. And then if you're somebody that enjoys the interval notation, it's just going to look a little bit goofy because you've got -4 and then you have -4. See, my 4s are looking so weird over 3. There we go. It's close enough is good enough. That's a little bit better. Okay, so the last couple of ones, less math, more writing. So here we're going to try to actually write an absolute value inequality dealing with persons being sick, dealing with body temperatures. So normally it ranges between 99.1 and 98.1. So pause the video and try to write this as an absolute value inequality using what we saw in the previous video. Welcome back. So here you're going to see, well, first I needed to find that halfway point between 99.1 and 98.1. So that's where I added them and I split them in half. Okay, so that's kind of where I got one of those numbers from. So there's 98.6. Okay, well, how far away is 98.1 from 98.6? And vice versa. How far is 98.6 from this one? Well, they're about half a degree off. So just be sure that's your final absolute value inequality, because again, we want to be less than or equal to 0.5 because we don't want to be beyond those bounds. Otherwise, we're going to be having a fever or we're going to be sick. So we want to be sure we're between those numbers. And if you tried to solve that, which is what's really nice, hopefully you'll get back to those two solutions. So you can always try to work backwards and you'll see you get the exact same answer again. All right, I want you to try example number 8 on your own. I think it's a really fun one. So try to write the absolute value inequality for each of these graphs. You'll see there's some commonalities in the graph, so use that to your advantage. Welcome back. So the first one, I went ahead and jotted a couple notes on my number lines to help me see. So you can see on the number lines, it's easier to find a halfway point. And then I can see that it's a distance of 3. And all of these have that in common. They all have -1 and 5 in common. So really, I'm just focused on open and close, and I'm focused on the inequality signs. So you can see that this first one, here's the or piece, because here's the ends. Here's an and, because it's bouncing between the numbers. Here's another and then here's another or. So for that first one, in blue, I went ahead and have, okay, x is -2 is greater than or equal to 3. So that's the absolute value. And again, I can try to plug in a number like 6. Okay, did 6 work? Oh, yeah, it worked out really well. Same thing on here, except I have open dots and I have an and. So it's going to look real similar, except it's a less than and it's not equal to. On the green, we can see it's closed and it's an and. So it's less than or equal to. And then the last one in pink, GreatOR with no equal to sign. All right, and the very last one is going to be a closing thought. So I wanted to see what you thought about something like this. So here's what would the solution be to this type of inequality? So A, B, and C are all just numbers. So you could pick numbers like 2, 5, whatever numbers you wanted. The only extra stipulation that I gave you is that C has to be below 0. Okay? Well, that's going to be all these negative numbers. So again, positive numbers are never less than negative numbers. No, absolutely. So remember, that type of situation is no solution. Because again, positives are never, ever less than negative numbers. Ever, ever, ever. And then the last one, I have a little typo, so I want you to fix that on your notes. So C, I'm still going to make it negative, but I wanted you to focus on what happens when I change that sign. So here it looks like this, and now it looks like this. Ah, so if you have the other way around, well, positive numbers are always above negative. So make sure on this one, you have an all real number type situation. So that's your negative infinity to positive infinity. So I'm just going to do a fancy R for shorthand. But be sure on your tests and quizzes and practice, use proper notation. Thanks for watching. We're going to do some practice in class.